Hello students, Miss Slyman here. I'm going to talk to you today about the remainder theorem. So if we were asked to calculate p of 4 given this quartic polynomial and we didn't have our calculator, it'd be super annoying. So if I was going to do that, I would do p of 4 is 4 to the 4th minus 14 times 4 squared plus 5 times 4 minus 3. This especially is a lot of just calculation that I don't want to be doing over on the side of my page. So now let's say we do have our calculator, so we can come and calculate it. So we've got 4 to the 4th, and then minus 14 times 4 squared, minus 5 times 4, and then, plus 5 times 4 minus 3. Go back and fix that. Minus 3. All right, so we get a value of 49. But now let's use synthetic division to divide our polynomial by x minus 4. So that means I'm going to put a 4 on the outside, and then on the that's not what I wanted to do. Let's do that. All right, on the inside, I'm going to go 1, 0 for my x cubed term, negative 14, 5, negative 3. So I'm going to bring down the 1, multiply, add. 4 times 4 is 16, add. 4 times 2 is 8, and I'm going to get 13. 4 times 13, that's going to be 12, carry a 1 is 52, and then 52 minus 3 is, my remainder is 49. Well, look at what we have here. We have 49 and 49. So it appears that p of 4 is equal to the remainder of p of x divided by x minus 4. This is super, super handy because it lets me calculate values really quickly. But more importantly, it lets me quickly know if something is a factor or not. So now if I want to find f of negative 3, I'm going to put negative 3 on the outside. And then 2, 1, negative 8, 5. 2, negative 6, add and get negative 5. Positive 15 is 7, and that's going to be negative 21, which leaves me with negative 16. So I can say f of negative 3 equals negative 16. And here is where it's really, really useful. So show that this is a factor. Well, being a factor is going to imply a remainder of 0. So that would mean that f of negative 3 should be 0. Well, I can test this out with my synthetic division. And also, doing synthetic division means that in the end, I know what that first division result is. So let me show you what I mean here. So I'm going to bring down the 1, negative 3. Gives me positive 3, negative 9, negative 10, positive 30, remainder of 0. Well, this tells me that right now my polynomial, my f of x, is equivalent to x minus negative 3, so x plus 3, times x squared plus 3x minus 10. Well, I know that this continues to factor, so that's going to be x plus 3 times x plus 5 times x minus 2. So my remaining factors of the polynomial are x plus 5 and x minus 2. So fully answering the question, x plus 5 and x minus 2.